Okay, now we're going to take a closer look at the graph of this. For example 2, we're going to graph the expression and verify what we found in example 2, example 1, sorry. And what we found, in case you don't recall, was that this answer, or this limit, was 0.125. Now, let's see if we can verify that on the graph. Because you have your three approaches for finding limits. One approach is analytic. That's where you use algebra and substituting techniques and things like that. 2, you could look at it numerically. We did that already in example 1. And number 3, you can look at the graph. Maybe the graph will help you decide what the limit is. Now you have to be careful with the calculator because sometimes the graphs aren't always what they appear to be. There's a limitation to the technology, so you have to be aware of that. And that affects numerically also. Things can go wrong on you if you're not very careful. So analytic, when you can use it, is probably the most robust of the three methods. A combination of the three, 1, 2, or 3 of these can help you to verify exactly what the limit is so that you're not in doubt. Now, in this problem, we were just going to look at the calculator. So let's see what we have here. Put it in, and it's really just a matter of getting the right window. So if I graph this, what I can see here, let's do a trace. I want x to come over the 4, so let's just immediately put in that 4. And okay, again, we see missing y. Doesn't tell you anything, but if you jump just to the right, 4.04, you'll see y equal to 0.1243, and to the left, just a little smaller than 4, y is 0.1252. We round it. So that might make you think that it's somewhere in the vicinity of 0.125. If you're not, if you had to cut it at 3 decimal places, you'd be safe to say 0.125. Okay. But if you're not certain of that, you might want to bring this up a little bit further to 0.125. This one, 0.125. Okay. A little less than 4, a little bigger than 0.125. A little bigger than 4 for the x, and y is a little smaller than 0.125. So it looks like it might be 1.125, but let's zoom in a little closer. So I'll just press my zoom in, enter. And we got a little bit closer look now. Let's see how that affects. Don't forget to press the trace button because we're not actually on the graph right now, not on the curve. So press your trace, and you can jump right to 4 if you want, and then go a little to the right. Notice the change in x was about 0.02. A little to the left, again about 0.02. So we're at 0.1251, 0.1249. If you were rounding to 3 decimal places, you could see either one of these numbers would make you think that it was 0.125. You would settle on 0.125. If you're still not convinced, you could zoom in again. So I zoom in one more time, enter. And I'll jump to the 4. Oops. I guess I have to trace first. Trace 4, enter. Okay, again, nothing. Now a little bit to the left, notice my x is 3.996. If I go to the right, it's still a little bit less. Let's get to past that 4. There it is, 0.1249. So if you round to 3 decimal places, you're definitely at 0.125. If you round this one to 3 decimal places, 0.125. No question at all. Very close. So that isn't a proof, but we'd be satisfied with the logic and the reasoning of our choice. 0.125.